questions below, and I'll respond quickly or in the next episode of Louis.
Hey everyone, how are we doing? Gotta turn a light over here. Bright lights, my eyes. How's everyone doing? Just chilling right now in the morning. Do we have any questions? I'm gonna get some new lights. I'm gonna get some new LED lights. Do some new lighting in here. Maybe I'll put in the orders. If no one's in the chat, I'll start looking up these orders. Gotta put in cookie orders. Girl Scout cookies. VFX. You're welcome, Alexander. Of course. Yeah, that's what we're here for. We'll throw you some U-Bot points. Definitely promote the Discord. Tell people Discord now. Do it. Get on the Discord. Get on the Discord. Need to go to the SharePoint. Put in requests. I want to get new lights. If people have no questions, I might try to order lights. Who is let me go look at this. Let's go LED lights. Gonna get some LED lights. Ooh, that's neat. We need the light grid. Here it is. This is what I saw. That looks really good. There it is. There's the light grid. I think it's got it. It can be controlled via the phone. I've never seen this one. That's Pro LGB. It'll be really good right there. Like, let's just do it. Let's make it really nice. Thinking lighting for gaming, streaming, Zoom, YouTube. If anyone has questions, let me know. I'm just figuring out what is needed. So, intelligent app control. These look really good. Like, I like the box. I'm gonna put them in here. Let me do this right now. So I've got this. I can do this a little bit later. And then, what is it? Elgato. Just trying to improve things here. Make things even better. That's what we do. Who has questions? We can do chapter 3 quiz. Well, we did chapter 3 quiz last night. Chapter 4. Chapter 4. Chapter 4. I think we need the Facecam Pro. A lot of my money right now. Then I need the arms. The arms. So every year I might just try to improve the office a little bit more. Key light. Oh, you can get a key light with it. Bundle. 2x key lights. I want 110 for the key lights. What's up, Savannah? Ask those questions in the chat. Brian's just checking out equipment to improve the stream even more. Lighting, we have pretty good lighting, and I got this light from Terry, this light over here. But there's better lighting we can do. And lighting is the key. If you ask camera people, lighting, if anyone does camera work right now, they know that lighting is the most essential thing to doing videography. So lighting is huge. What kind of mount does this have? So I'm trying chapter 4 quiz. Need help? Let's do it. Chapter 4 quiz. I'll look this up later. Trying to think what mount it has. Tell me the mount this has on the bottom so I can mount it. I wish it would just say, like, it has this mount. Use this mount. 2 seconds. I don't see where it talks about the mount. Well, we'll worry about that later. Actually, it has a clip on it. Let's do chapter 4 quiz. There are companies in Haslam today. In the employer of the day, handing out chicken biscuits. Go and talk to them. A lot of supply chain people they're recruiting. And there is the Welcome Wednesday today. So check out Welcome Wednesday. We're logging in here to MyPearson. How's your day going, Savannah? Welcome Wednesdays. Great, going great also. Just a nice morning, just a nice chill. It's like nice outside these days. It's just a light jacket. I think that's the best kind of temperature, is light jacket temperature. Chapter 4 quiz. Which questions are you doing on chapter 4? Chapter 4 is really good. Very nice. Which question? Tell me the start of the question on chapter 4, because I about have it open. Chapter 4 quiz due on the 8th. It's coming up here. We already finished chapter 4. We're right on track. We're doing really great. Okay, got the screen open here, chapter 4. Let me know any question you're working on, the start of it, the first like 3 words of it, and I'll go find it. Question about top part 1 crowd management strategies, monitoring rock concert. Yep, I know that one. I know that question. I've seen that one. It's got interesting data. Let's go find that one right here. All right, here we go. Main screen. Let's do this. Okay, let's go find the rock concert. There's like 2 versions of this, so we'll do both versions right here. I'm gonna find it and mark it. 2 versions of this rock concert one right here. I'll give you all about. They're like, oh man, the students love rock concerts. Let's talk about rock concerts. These ones are weird. The traveler ones with eggs, and here we go. Accents at rock concerts. We found it. So here we are at 11:23, and we have Stat 201, Chapter 4, MyPearson Quiz. And it is crowd management strategies. Okay, crowd management strategies. So let's look at this data here first and see what we got. What kind of data is this? What 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 are these graphics right here? Think about what these graphics are. I mean, you get points for saying the obvious or what it says. And these are the age. That's a quantitative question. So what are these graphics? That's what we're asking right now. Histogram right here, univariate display of quantitative data, and boxplot over here as I lag behind for a moment. Boxplot is a univariate display of quantitative data also. We have just different ways of displaying the data. It's very easy to see where the outliers are at, like someone who's like 36 and 46, and then the median is around 19, the Q3. Let's mark this with drawing on it. A box plot is a graphical display of the 5-number summary. So you should know when you have a box plot right here, if you see one, you should know where the values are at. Like the min is the lowest value, the max is the highest value. The top of the box is Q3, representing the 75th percentile. The bottom of the box is Q1, and the median is the line. Often you can see it unless it overlaps with some other quantity. Do know that the range is right there. That's the range. And then the IQR is the length of the box. That's about all the information we have. There might be a few other things. There's a gap in the data right there because there is no data. And we have 2 outliers. So understanding this information is good. Now, here goes to test questions. Which of these gives you a better understanding of the shape of a distribution? Histograms or box plots? Once again, I try to teach the test a little bit by looking at my Pearson question. Which of these gives you a better understanding of the shape of the distribution? Histogram or box plot? Histogram, you're right, Savannah. Histograms show you the shape where box plots might hide important features. Box plots might hide important features, but they're great for comparing multiple distributions. So if we had like different concerts and we looked at the ages of different concerts, like concert 1 versus concert 2 or concert A, B, C, we could compare the ages for each of the concerts. I'm going to try turning off the second camera after this question because I swear that might help with the lag, the latency. Okay, what features of the distribution are seen in both the histogram and the box plot? Well, we can tell that there's the 2 outliers right there. And most victims, I think, are between 16 and 24. So you can see right here, 16 to 24. Also, the box plot shows that right there. So that's going to be right there. You've got the right skew, and you can see right skew with the box plot because it's pulled out more on the high side, like from the min to the Q1, especially up here where you go to the Q3 to the max. It's pulled out. Easier to see it in the histogram, though. The histogram shows the skew basically better. What feature of the distribution can be seen in the histogram that can't be seen in the box plot? Once again, this is a shape idea. Histograms are better at shape, and you've got this second modal area, so you got that second bump right there in the distribution, and you don't see that in the box plot because you don't get a really good idea of shape with box plots. You can kind of tell a little bit, but histograms are your #1 way to look at shape. So it'd be the slight increase right here, the second modal area, modality. What summary statistics would be chosen to summarize the center? Okay, this is a very important question we've done a lot. What are the 2 options for center? I'm not asking their answer yet. Don't worry about what they're saying. What are the two options for center? This is how we focus on knowing the test. What are the two options for center? What are the two options? Mean or median? And then we choose mean if it's more symmetric and median if it's more skewed or outliers. Is there skew? Is there outliers? So what's the choice, Savannah? What's the choice? You got this. What is the choice? You know it, you got it. So which one is it? And yes, there is. So which one is it? Median. You got it. So the correct choice, and just don't read their answers, practice and be ready and know the answer. So we got to look for median, and we have right here. And look, they even say like symmetric. So the only two possible answers would be mean because it's symmetric, median because it's skewed with outliers. So you only have two possible answers here theoretically, and then you just have to see is it skewed with outliers. What is going to be chosen to do the spread? What are the two possible answers for spread? So the two possible answers for spread are what or what? What are the only two answers for spread? You can see one of them right here. This is one of the spread quantities from Q3 to Q1, that distance. The other one talks about a typical distance from the mean, standard deviation or IQR. Standard deviation is the typical distance something is from the mean, because how much do things standardly, like on average, deviate? That's what we call it, a standard deviation. Like what is a typical deviation? We should just call it that. Instead of standard deviation, we just should say average distance from the mean. It kind of is. This is basically what it is. It's average distance from the mean. Let's no longer call it standard deviation. Let's just say something's average distance from the mean. The average distance points are away from the mean, because that's what standard deviation is. Is the quiz or homework? This is the quiz. Hey, Catherine here. Just ask any question you want. I'm trying to fix the camera between this. And so the reason we know it's IQR here is because it's skewed, and skewed is median, center, IQR spread. Is this one the one you wanted? There might be another one. Because of skew and outliers. Really good quiz. This is, sometimes I get mad at MyPearson. My quiz is a question. Is this the same quiz? Yep. This is all the possible questions, and you just name a question, and then I do it. I'm gonna try to turn off the second camera here real quick. You're gonna see me, another me. Where's me? The extra me? There should be two me's. There's me. And a little higher def me right there, because we got to get better lighting. Let me go to the second camera, see if I can turn it off. I so rarely use this. And does that turn it off? That's record. Oh, let's record a video or something. I don't remember how to turn this off. I want to see if turning off this camera might help. I can turn it off. Can we do the histogram and summary statistics? You bet, you bet. I'm gonna do 2 seconds on this. See if I can turn it off. You think it'd be right here. Settings, application. Better be careful, I could mess something up. I wonder if I just unplug it. This is called bad idea. Called a bad idea. Bad idea. Bad idea. Well, it shouldn't be getting a signal right now. All right, good. Okay. We'll see if that helps the signal strength here, and if I get a better quality. It's just been one of my theories, okay? Be like, what have you done? Things are still working. Okay, let's do the next question right here. Seems to be good. Just had some latency in trying to fix that. Histogram and summary statistics. Let's go find that. Keep dropping those questions. We're just going to do every question people say. So if you see one like question number what, that really helps me. If you say question number 16, here we go. Histogram and summary statistics. Really good one. This one's a tough one. Savannah, you're picking out some tough ones. Great right there. People are going to like that when they come back to the video and be like, oh man, this was my question and it was a tough one. So this graphic right here is very clearly what way? Talk to me about it. Talk to me about it. Don't read their answers. Don't read their answers. Talk to me about this and understand what's going on here. Skewed to the what? You got it, Savannah. More points in the chat. Keep those answers coming. Get to the highest level of points. Skewed to the what? Great job, Kylie, right there. Once again, get in the practice of not reading their answers, because the more you don't read their answers, the better you get at understanding the material, and then you can look for the answers in their answers. Don't read their answers. See if you know the answers before they give them. So what you see over here is the 5-number summary. We got to draw Monster Man. What up, Monster Man? Good morning to you. He got that right. Skew right to the high, left to the low. What would any of those be outliers on that histogram? Really good question, Alexander. So do you notice here we have these summary statistics right above my head right here? So we can do analysis of outliers via a box plot. Now this one works a little bit better if you draw the box plot. We have the minute 0. That's going to be the line right there. We have the Q1 at 28. We have the Q3 at 78. We have the median at 43. There's the box. We can figure out where the upper fence is, which there's a small chance I'll throw you 100 points, but I might get one of these wrong. So don't click submit on your quiz if this is the last one. You bet right there, Olivia, we got it. The company that sells frozen pizzas. Oh man, I love frozen pizzas. That's talking about some DiGiorno's or something, or California Pizza Kitchen. You bet. We'll do that one next. So now we have the we know what the max is. The max is over here. These are outliers. This is easy. What is the IQR? Who can find for me the IQR? The IQR is what? What is the IQR? This is easy. The IQR is what? Yes, it's 50. And then great job, Alexander, right there with 50 points for that. So now what is 1.5 IQRs? Because remember, we go up 1.5 IQRs from Q3 to find the upper fence. And there is the lower fence would be down here somewhere. It doesn't really matter.
It doesn't matter.
There's no low outliers. But we go up 1.5 IQRs. So we go to Q3 and we go plus 1.5 IQRs. We found the IQR by subtracting those two values right there, Q3 minus Q1. So we'd go up 75. That's 50 times 1.5 is 75. And then we go up, great job, Olivia, right there. From 78, we go up. So we're going to 153, which is it's hard to tell if those are outliers. And so these could be outliers right here. Like they could be, that's an outlier, and there's 2 dots because of that height. The height of the bin is how many, so see how that's a little bit higher, and it goes over to 2, there's 2 dots right there. Are those outliers? Maybe, I don't know. Not my favorite question, it's a little tricky. Oh yeah, you can still see the right skew nature and extreme outliers right here. The histogram shows it a lot better. Once again, we see histograms show the shape where box plots might hide important features. Don't forget that. I'm literally saying a test question. Box plots often hide important features like the shape. They're good for comparing multiple distributions though. Okay, let's take a look at the questions now and see what they want us to answer now that we've analyzed the data a bit. Because the distribution is skewed to the right, the blank should be used to describe the center and the blank should be used for the spread. Pretty easy questions. I'm going to let you answer it. What is the proper measure of center and spread respectively for a right skewed distribution with high outliers? What is the proper measure of center and spread? Median and IQR. Boom, we get to the test. We're like freebie answers. I know these. I've done these a lot. This is the one I sometimes get wrong. Oh, you see, look, it says 3 to 5. Ooh, you see how else? Maybe I should have done it better. Maybe future Brian's better than past Brian. Great job. We're going to make Catherine a mod. I'm going to go a limb here. Usually I do this during class. Catherine, so good to have you here. 20 points. We got 1, 2, 3, 4, 5, and I didn't know if those are outliers. They're kind of iffy ones. So we'd go right here and we would say there are 3 to 5 outliers because here we go. Remember, outliers are defined as more than 1.5 IQRs above Q3 or below Q1. So the 1.5 is the magic number to remember, and we cover that in the lecture. So take that note and put it down. This is the note. Outliers in box plots are 1.5 IQRs. You're welcome, Catherine. 1.5 IQRs above Q3 and 1.5 IQRs below Q1. If their values past 1.5 IQRs, so Andrew, really, and great question, Andrew, right there. The definition of an outlier via box plots are things that are more than, and this is where the fence is at, it would be things that are beyond this line, and it's hard to tell if these 2 dots right here are outliers. And because this is 1.5 IQRs above, and we might have drawn it weird, but it's supposed to be 1.5 IQRs below. There are no low outliers. There are 3 to 5 high outliers defined as 1.5 IQRs above Q3 or 1.5 IQRs below Q1. Hence why we ran this formula to figure out where the upper fence is. And the upper fence was at 153. And then I tried to draw the upper fence right there. So that's what I'm drawing with that line. Does that make sense with my bad handwriting? The mathematics to remember is 1.5 IQRs above Q3 or 1.5 IQRs below Q1, high and low outliers respectively for box plots when median and IQR are used. That is the concentrated knowledge right there. We should get that one right. here's the box plot, and now it's asking us to draw it, so it is giving us an idea of what's going on. Some of these are really laughably bad. Like the median, or excuse me, the Q3 is 78. So if we look right here, that one has a much higher median than 78, so B is wrong. This one still looks too high for me. That one looks kind of good. I'm looking to see this thing right here, if it's right. That looks kind of good, looks close to it. 78 should be close to 75. So I'm looking at this line and seeing if the Q3, as seen in the output right there, is where, because that's the top of the box. And then this is where 28 should be. That looks, no, this might be the right one, because that's about 28. Looking over there at the data, and then there's 1, 2, 3, 4 outliers. Extreme outliers are more than 3 IQRs above Q3 or below Q1. And remember we calculated that line? Oh, that's got it. Do you remember we calculated the upper fence at 153? So this is it, because, well, it's really iffy. It's pretty iffy because it's hard to tell. I'm pretty sure it's C. It's just let graphical software make it for you. But there's some obviously wrong ones due to spots on it. Trying to see if I see anything. Q1 and the median are a good way to check that. A little tricky. Now this is the one that gets me, I think. This is the one where I make a wrong thing. We'll maybe get 100 points. The distribution of number of campsites at public parks in Vermont is, pretty sure it goes by unimodal. It's not uniform, because uniform is a what distribution? Uniform is a what distribution? Uniform is a what distribution? Looking for a 4-letter word. Uniform is a what distribution? Uniform is a what distribution? 4-letter word. Uniform is a what distribution? It is symmetric, but uniform distributions are flat. Uniform is flat. Flat. Great job, Kylie, right there. They're flat. It is technically symmetric. You're right. I got another 20 points for that, or 50. It is technically symmetric too, but more notably seen by its flat nature. Uni meaning one form, flat, like there's no peak to it. Where unimodal means one area of concentration, modality. It doesn't mean one most common number like modes are. It means an area of concentration. I'm pretty sure this is unimodal, because usually you want to see a stronger second peak to start talking about bimodality. I could be wrong here. A little bit subjective. There's some evidence of second area of concentration, but maybe not strong enough. A lot of people say, when is there enough evidence? It's really subjective. Like, this is clearly unimodal. This is slight bimodality. This is definitely bimodality. So you definitely have like unimodal, and then some statisticians might say that's bimodal. I probably wouldn't. And then this is definitely bimodal. Does that make sense? Where there's subjectivity of when is it bimodal? The top one, that's unimodal. It's kind of still unimodal in my book. And then this is bimodal. You could even put an in between these and go something like this, where most people are going to start to say it's bimodal. But it's a subjective thing, but it's pretty unimodal. One clear peak, little extra on the side. Hopefully MyPearson doesn't disagree. And it's skewed to the right. Already talked about that. The center distribution is approximately, center's right around here, so the 30s, 40s, 50s. Ooh. Okay. Really, 35 and 44, you're going to do that to me? Oh, let's just go to the median. There we go. Round up to the median. Good answer. Because remember we talked about the center right there. The distribution of campsites is it tightly packed? No. It's quite spread out. These parks have in excess of, and then we look right here, and 153. That was the upper fence we calculated, right? Oh, come on. I always get like an 89.9 on this. Not today, MyPearson. Not today. Woo! Yeah! Not today, MyPearson. 100 points. Yeah. Take that. I made MyPearson flinch. Yeah. Not today, MyPearson. Not today. Not. Okay. Really good question. A lot of fun. Once again, go through and do the steps to practice. the better you can draw these things out, and the more you can know their questions before they get to them. Like, we were already ready with that 153. We knew that number in our head. We said, wait a minute, the center's the median. I'm going to go up there and grab the median for that answer. We knew right to the high, left to the low, whatever way the monster man's tail goes. We know what unimodal is and bimodality is. You know those words. Comparing box plots, you bet. I'm having too much fun right here. Put on that serious face. Okay, let's do it. We got 8 people watching here. The question right before this little chill music, Brian's got to calm down a bit. The question was, next, could you do the company selling those frozen pizzas? Oh, man. In 4 markets. I'm going to mark both these questions right here. Company selling frozen pizzas. Is he company selling frozen pizzas? Sometimes I wonder, my department might hear me and be like, what in the world's going on, Brian? Just go in your office and start yelling. The company's selling frozen pizzas. Man, there is a frozen pizza that is not just cheese stuffed crust. It is cheese across the whole bottom. I think DiGiorno's makes it. It's just cheese, like cheese stuffed pizza. And they even say on the box, like, don't eat the whole thing. And I'm like, you can't tell me what to do. I'll eat the whole thing if I want. I didn't, but I thought about it. Too good. DiGiorno's is pretty decent. Like in a pinch, DiGiorno's pizza works. Found the frozen pizzas. What's your favorite pizza? In the comments below. MyPearson Quiz. Oh yeah, let's do this question here. What do we see? What's this graphic called? Tell me the name of the graphic. Get some points in the chat. Tell me the name of that graphic. It is a bivariate display of categorical quantitative data, as in a categorical X variable and a quantitative Y variable being displayed here. This is ideal for comparing multiple groups. Savannah, you get 20 points for that. Keep going a little bit further. It is box plots. But we call it what by what box plots? You bet, Alexander. I'm going to grab that question. It's not just a box plot. It's not just a box plot, though. You're right. It's a box plot. But is it one box plot? What's better than one box plot? 4 box plots. So we don't call this a box plot anymore. You're right. It's there's box plots there, but we don't call it a box plot. We call it what? Because this is the bivariate version. It's no longer a box plot. It's side-by-side box plots. 50 points in the chat right there. So it is side-by-side box plots, a bivariate display of a categorical X and a quantitative Y. So you see those are the X's on the far side. Like if you go this way, you're looking at the X variable. If you go this way, you're looking at the Y quantitative. So they are bivariate, categorical, quantitative. Good work right there. Know this graphic. Take a picture of it. So once again, if you haven't, take a picture of this, pause the screen, and know it, write it out. Really helpful to have that information. Do the prices appear to be the same in all 4 markets? Let's take a look. Tell me comparatively, if you were where you would expect on average a higher pizza cost, or just regularly to see higher pizza costs. Where would you expect higher pizza costs? Look at the information on the screen and tell me, where would you expect higher pizza costs? Not really on average, but 50% of the time, I should say. 50% of the time you'd see higher pizza costs where? Like, pretty, yeah, this is a jump right here. Baltimore, the median of Baltimore is very high. So Baltimore kind of stands out. I don't know what's so great about Baltimore pizza. Nothing wrong with it. It's just, I don't know. I'm a New Yorker, so sorry, Chicago, but you make your pizza too deep. You got to have that floppy nature to the pizza. You got to pick up the pizza, fold it, a little bit of grease drips off of it, and just like, yeah, good pizza right there. A little bit of grease, not too much. Do prices appear to be the same for markets? No. Prices appear to be higher on average and more variable in Baltimore. Yeah, and more variable kind of. Chicago has variability from min to max, but also the IQR is bigger for Baltimore. So that's variability measured too. IQR being this box, so that's what they're pointing to. There's more variability in Baltimore and the median is higher. So Baltimore does appear to have more variability via larger IQR, which is a measure of spread, and then also has a higher median, which indicates higher also. So good stuff right there. So does the presence of any outliers affect your own conclusions about the four markets? I mean, there's extreme values in Chicago. Man, you go to $1.50 a slice, I'll get some 2 slices for that, get a Coke, $5 meal. So we should definitely use median and IQR because there are some outliers here. So, I mean, yeah, we should use median and IQR, and there's some extreme values. Well, probably I'm going to look at the yes answers, see what the yeses say. Yes, Chicago is the one. Let's average. Yes, Baltimore's outliers increases its range compared to the ranges of cities without outliers. No. Yes, Dallas's outliers increases its range compared to. No, it's more of a Chicago has extreme outliers. That's the one that I focused in on first. I don't really like how they asked that, and I could possibly get it wrong. They're gonna. Oh, it's because they're focusing on Baltimore. Really? No. Oh, okay, really? They're talking about the previous question. We gotta throw 100 points. They're talking about the previous question. And so why does the presence of outliers not affect our decisions about medians? So why does the presence of outliers not impact our decisions about medians? Why does the presence of outliers not impact our decision about medians? That's what the question should say. 100 points in the chat because I got it wrong. Why does the presence of outliers not impact our decision about medians? Medians are not influenced by outliers. So like it should have said that. It should have said, with what you just decided about medians, why do outliers not impact that decision? Well, not because we can take them out. Alexander said it perfectly, another 100 points right there, because the last question was talking about, it does say, it talks about average here. Man, I don't like it. It didn't say medians. I think that's why they were throwing me for a loop. You should compare median. It should say medians. I might even talk to MyPearson about this and should say Baltimore has a higher median. Yeah, they shouldn't be comparing. We can't really see averages right here really well. I mean, you can kind of guesstimate them from a box plot, but they should say Baltimore has a higher median. And then they should say, why does your conclusions about medians, why is it not influenced by, or like, why would it not change due to outliers? And it's because the presence of outliers does not impact because medians are not influenced by outliers. Really don't like that question. Man, well, it's not because I got it wrong. Let's do the next one right here. When I did one of the harder questions, I can't get multiple choice. What's going on? What's going on? Harder questions are easy. Easy questions are harder. The world's turned upside down today. We got to get one wrong during office hours. It shows you're human. It's all right. I'm just trying to put myself back. Let's do this next question right here. The next question is, when comparing the box plots of two groups. When comparing the box plots, drop more questions because we're running out. Yeah, outliers influence the average. Very much, Olivia. That's why I really don't like that question, because outliers influence averages. Outliers influence averages. So that's very true. Outliers influence averages. Outliers do not influence means. Very important to know this. Okay, with this question, when comparing the box plots of two groups, which of the following should be done? Should we compare medians? Did we just do that a moment ago? That Catherine, we got that here on the list. Did we just a moment ago, yes or no, compare medians to see which one's the highest and talk about kind of a central theme or the center of the distributions? We did. Compare the IQRs to see which one's more spread out. Did we just compare IQRs? Did we compare IQRs? Yes or no in the chat for more points. We keep throwing points here. You bet we did. Did we look for outliers with the box plots to see if there's unusual things like outliers, which are unusual features, like gaps and outliers are unusual features. So you have shape, center, spread. Part of shapes, yep, we did. And do we compare the shapes? This is harder to do. You can, if you want to really compare shapes, make a histogram, because box plots can see shape, and the question is, why not both? I'll throw you a 100 point. If you can quickly tell me from yesterday's class, I'll throw you 50 points for a guess. What is the graphical name for the graphic that compares is a box plot that lets you do both? Does anyone remember the name of it for 100 points? I mentioned it yesterday. So if you really want both, you could just do what? Then you can see the shape and you can see the quartiles. Good guess, 50 points. It's called a violin plot. So these are violin plots right here. No, so I'm saying because the box plot doesn't let you see the shape, the histogram does. So people make what are called violin plots, which have the histogram here and the box plot around it. So you still get the 5-number summary, and you also get the density shown by the histogram telling you what's going on. So the violin plot, which is not covered in Stat 201, is going to give you the shapes that the histogram shows, but also give you the quartiles that a box plot would show. So really good stuff, and there's the IQR. So really good summary of here. It's showing you box plots versus histograms, and the violin plot is both put together. So you can compare shapes in a box plot, but histograms are going to do better. You can do it. The Department of Energy, you got it. Wouldn't medians be good at looking at a measure of center no matter what? Kind of. A lot of people do that. Alexander, 50 points right there. Good comment. Some people just swear by the median. But here's the thing. When a distribution is unimodal symmetric, what would you know about the mean versus the median? When a distribution is unimodal symmetric, what would you know about the mean versus the median? When a distribution is unimodal symmetric, what would you know about the mean versus the median? When a distribution is unimodal symmetric, what would you know about the mean versus the median? We'll do that when you got on the list here, Savannah. Thank you so much. Thank you, everybody. We got a bunch of questions here in the chat, and we're going to keep rocking and rolling through them. When a distribution is unimodal symmetric, what would you know about the mean versus the median? When a distribution is unimodal symmetric, what would you know about the mean versus the median?
It doesn't matter!
When a distribution is unimodal symmetric, what would you know about the mean versus the median? Alexander's a really good question right here.
It doesn't matter!
What would you know about them? Take a look at this graphic right here, mean and median. Unimodal symmetric. They're the same, so it really doesn't matter which one you use. So a lot of times people say, like, to say on average, and that's fine, especially with symmetric data, and that's what I prefer to say, like, well, on average we see this. If it is symmetric, then yeah, the average is the median, so you could just use median. If skewed, use the median, because the mean will be going in the direction of the skew. You can see the median right here. The median is not influenced by skew, it's the 50th percentile. Outliers and skew do not impact median, they impact the mean. So the mean is biased, like pushed in the direction towards outliers. So you can see right here, really good graphics showing you the mean follows the skew. If it has right skew, right to the high, left to the low, whatever way the Monster Man's tail goes, the mean goes in that direction too. Mean goes with Monster Man. So there's our Monster Man there, right skew. There's our Monster Man there, left skew. You will also hear people say that this is negative skew and this is positive skew, hence it says up there, but right to the high, which is the high side, left to the low. So know your Monster Men right there. Monster people. Okay, next question is, sugar is a major component of everything, unless you get sucralose and everything. I need to find new protein bars that are low sugar but don't use sucralose, stevia. I got some Quest protein bars, they're good, but who's got suggestions for Brian in the chat of good protein whatever? We'll listen 3 times, so. What is a good, what should I get? Metrics? I think I got metrics. I think they have real sugar. They're kind of high. Metrics, they're like a meal replacement bar, 32 grams protein. I do have some of the metrics. I got like the pretzel peanut butter one. Pretty good. I'll admit that. A little high in sugar though. A little high in sugar. I'm becoming one of those people who's like, what are the macros? What happened to me? What happened to the old Brian? I miss him. But no, that's a good suggestion, Alexander. I like that right there. Like, I want my protein bars to taste all right and then be decent on the macros. I never thought I'd be saying macros. I learned too much. I watched too many YouTubers. Here we go. Sugar is a major component of breakfast cereals. Got to get your sugar in the morning. And with this right here, we have, I got to mark this question. Sorry. 2 seconds. Forgot to put the timestamp. I'm going to save the timestamp. Forget. 44:53, Stat 201, Chapter 4. MyPearson. Good to see you, Blakely. We're rocking and rolling through this. Gonna hit save. That way we don't get at least half of it if we lose it. So what is this graphic called? What is this? This one's bivariate, this one's not. What is this graphic called? What is this? Try to name either of these graphics. Remember, this is the review to remember when we have a bivariate display. It is a box plot. It is box plots. You're on track, Savannah. We're going 350 points. It is box plots, but we would call it what? It's not just a box plot, though. There's box plot in there, but it's not just a box plot. It's side-by-side box plots, meaning bivariate, because we have here an X that's categorical and a Y that's quantitative. Things why it's side-by-side, you're just breaking the box plots into two groups and comparing them to each other. It's super duper easy to see that children's cereal, we love it because why? When you look at children's cereal over here, we love it because it what? It what? Children's cereal what? Nice job on the bimodality right here. There is bimodality. It's good. Why is it good? Oh man. Oh man, it's super duper sugary. So comparatively, we can see that children's cereal, like even the lowest children's cereal has more sugar than the highest adult cereal, because here's the highest adult, and that's just telling you where the children goes up to and the adults go down to. But the highest adult cereal has less sugar than the lowest children's cereal. Things like that we can see. Now this is all the data right here together, and you can see the mode from adults and the mode from children. So this is bimodal, meaning two modes, bimodality, two areas of concentration of the data. And so yeah, let's check it out. To get the range, subtract these numbers right here. I'm going to move my head 2 to 66. You would not want to do the bins of the histogram, because the bins of the histogram collect the data into the groups. You can't tell what the highest number is. We would just know that the highest value is somewhere between what and what. The highest value is somewhere between, and the technicality is it can go up to but not include the last number. But the highest number for sugar content in cereal is somewhere between what and what. We do not, from the histogram alone, we would not know that. So don't use the histogram for this answer. Somewhere between 60 to 70, great answer, Savannah, right there. We don't know it because the bins of the histogram just collect the data in there. So the answer is it's 66 if we look at where they marked it. This question used to not mark it, and good job on them for correcting it. 66 minus 2 is 64 because they show you the max and the mins on the box plots. The shape of the distribution is definitely bimodal. What aspect of the breakfast cereals might account for the shape? It's subjective. Children's cereals have more sugar. Yeah, that's it. They should just say adults versus children. Are all children's cereals higher than adults? That is true. That's the lowest children's cereal. That's the highest. Would the side-by-side box plots diagrams show the outliers if they were any present? Yeah, good question, Alexander. They would. If there was an outlier, you would see it. Good question. The pizza one, I think, did that. Yep. Yes, they're all higher. Which groups of cereals varies more in sugar? So variability. So take a look. What is a measure of variability we can see from box plots? There's two of them. What are the two measures of variability you can see in box plots? I'm going to give you a hint. This or this. What are the two measures of spread you can see in box plots? I'm talking about this or this. Can't reach all the high on that. What are the two measures? Range and IQR. Not standard deviation, though. Good answer. Those are the two measures that we choose between. And when we look in through some 50 points right there, so this is the range of the data, the min to the max, no outliers. So this is the min to the max. And then here is the IQR. We don't typically use range because it's impacted by outliers. So we have the IQR here. This one's a bigger IQR. And the ranges look to be about the what? So the ranges like of children, the range of adult cereal looks to be about what? The range, and good job, Avery. The ranges look to be what? Ish. Here's the range of children. Here's the range of adults. The ranges look to be about equal. The IQR, though, adults have more variability in their IQR measured by the range of the box, and children have a smaller box, meaning 25th to 75th percentile. Okay, although the ranges appear to be similar, the IQR is larger for the adults, and that should do it. There we go. Good question. Good question, MyPearson, because I got 100. That's a good question. Okay, next one, we have histogram of assets of 79 companies. We are rocking and rolling. We're getting a lot of these questions done, and probably the hardest ones. How are people doing? Do people already have hundreds on this quiz or near hundreds? Thank you for showing up early to get it done. Just show up early to these office hours and start working on the next quiz. Just get it done. Be like, I'm going to show up early. I'm going to get it done. That one's a tricky one. A lot of people get that one wrong. You might want to do that one. What is it called? I was looking for a video on it last night to send somebody, and I was like, dang it, a class of 4th graders. That one has a tricky one at the end, which a lot of people are like, wait, what? Wait till we get to it, and I'll do that same, wait, what? I'll lose my voice over that. National Vital Report. I remember that. Oh, here it is right here. We need to, let me mark it. National Vital Report. We're going to come back to this. National Vital Report. Thank you so much. Some people say question number 4, and I'm like, I have a different order. All right, I got it on the list. So if anyone ever has to go, as long as I get it on the list, we can do it, because then I have it on the list. What do you put about chill music? No way, box plots are the opposite of histograms. Yes, let's grab that one. They give you a better, they give you the 5-number summary. This might help, Savannah. They give you the 5-number summary. They don't show shape as well. They focus more on quantiles and stuff like that. We're looking for the 79 histogram of assets. Uh-oh. Didn't see it. Histogram of assets of 78. There we go. Let's do it. Okay. Histogram of assets. Need to remark the time. Got to start marking the time before I get to the question. Here we go. Here's a histogram of assets of 79 companies chosen from a list of nation's top corporations. Complete parts A and B. Okay, so here we go. Okay, what is this? What is this data? Talk to me about it. Talk to me about this data. Let's answer every question we could about this data before they even ask it. We're going to answer our own questions here about this data first. What's going on? First thing we describe, you got it right there. We've got some points in the chat. We talk about the shape right here. You got a right to the high, left to the low, whatever way the Monster Man's tail goes. And that is a super duper Monster Man, because that is very right skewed right to the high. High side, left to low side, positive, negative skew. There are some extreme outliers, it seems. If we box plotted this, which I'm just doing a quick sketch, you would get something like this right here. Notice box plot's pulled to the right side. Cone-headed Monster Man. He's all right with that. He's got that cone head. Super duper modality, very highly skewed, high kurtosis. We don't even talk about kurtosis in the class. Kind of peakedness, but Wikipedia says it's not. Whatever Wikipedia, I call it that. So with this right here, what is the proper measure of center? What is the proper measure of center? Middle 50% probably is more densely packed. What is the proper measure of center? I'm going to redraw my estimated box plot. Boop, 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 boop. Something like that. Median. What's the best measure of, so the median is the measure of center. What is the measure of spread for this? Measure of spread is going to be what? IQR. Boom. We got it. Test questions like that are freebies if you practice them a lot. So, sure. Let's see what the question asks and see if we can get it right. And thank you so much. This is a great question. I love it because we're going to ace it. So this question asks us, what aspect of this distribution makes it difficult to summarize or discuss center and spread? It's very right skewed, so that's basically it. I mean, yeah, it's very right skewed. We can still do median and IQR. What would you suggest doing with these data? Oh man, they're going this route. They're gonna say log it, transform it. So this is interesting. Basically, you can normalize data. Kind of an iffy question for you guys. If you square things, it makes them more extreme, but you can log things to make things more normal. And the way this would work is, think about this. What is the log 10 of 1? What do you have to raise 10 to get 1? Anything raised to 0 is 1. What is the log 10 of 10? So what do you have to raise 10 to get 10? So try answering that one. The log 10 of 10 is what? This won't be on the test. The log 10 of 10 is what? When you take log 10 of 10, you can cheat and ask your phone if you want. Say, what is the log 10 of 10? 1. What is the log 10 of 100? What is the log 10 of 100?
For example, the logarithm of 100 to the base 10 is 2 written log 10, 100 equals...
I just wanted you to say 2. It's 2. What is the log 10 of 1,000? So notice the pattern here was the log 10 of 1,000. Ask your phone if you want. What is the log 10 of 1,000? So think 1,000, 3. What is the log 10 of 10,000? 4. What is the log 10 of 100,000? 5. So notice that these extreme values are getting sucked in because the log 10 of a million is 6. So when you do the log, you pull in extreme values, and this is called re-expressing or transforming data. Won't be on your test. Okay, that's all I gotta say about that. Iffy question. I mean, remove all values. Can you just, this is a good thing right here to mention. Can you just delete outliers without reason? Just be like, I don't like these things, I'm just gonna make it symmetric. You always gotta give context for removing things. You can remove things and talk about with and without, but there has to be reason. Use an inconsistent scale, that just sounds ridiculous, don't do that. And if you square things, they become more extreme. So like think the square of 2 is 4, the square of 10 is 100, the square of 50 is 2,500. I did some easier ones, 5 times 5 is 25, add the zeros. So the more you pull data out when you square it, you squish data in when you log it, and logs is one of the things a lot of people, it's just a weirder concept. Because you have to ask like log 10 of 1,000, what do you raise 10 to get 1,000? The solve of it. Okay-ish question. You get an okay on this one. I should grade these. Like this is an okay question. Not my favorite. I'm marking the times again. What am I doing? I said I was going to stop doing that. Okay, we are doing the U.S. Energy Department one, but keep dropping questions if you have them because we have a lot of time left. I'm going to check out K-Brew today. Has anyone had K-Brew yet? What are your thoughts? Drop your thoughts on K-Brew in the chat right now as we find this. So drop those K-Brew thoughts. 2-7 on mine. In a way, box plots are the opposites. We got that one coming up here. About 4 questions. Thank you, Catherine. We got that one coming up. 4th grader one. We should do that. The U.S. Department of Energy. Here it is. That's stat 201. 56, 53. Okay. Stat 201. Stat 291. That's not our class. The National Vital Statistics. That one's coming up 2 questions away. Caroline, thank you for asking. 2 questions till that one. You got it. Here we go. Click the icon to view it. Woo. Group 1, Group 2, Group 3 on these side-by-side box plots has the least variation and least spread. Like variation measured by range. Group 1, Group 2, Group 3 has the least variation, least range. Group 1, Group 2, Group 3. Notice how we can compare these nice and easy on their 5-number summaries. Star reports. Oh, nice. Well, down. I got that mark, Savannah. Group 2. What really jumps out about Group 1? Box plots are ideal for comparing multiple groups. What really jumps out about Group 1? Help travelers, you bet. Thank you, Savannah. Might add that 4th graders. I'm gonna add the class of 4th graders. Because someone's gonna ask it and I want to put in this video. Low outliers, I like that. But check this out, the median right here. Yep, and yeah, right there. The fence would be hard to tell, but it's somewhere it's invisible because we don't see them. The median of Group 1 is much higher than the medians of Group 2 and 3. I'm just going to call them 1, 2, and 3 for all intents and purposes. Remember, you can just use numbers to define groups. So we see like spread. This has the highest IQR and similar range to the other one. Group 1 has a moderate spread of IQR and maximum range with low outliers and highest median. Group 2 has the median and Q3 are kind of on top of each other from what I can tell. It's very hard to see because the lines are really close, but even Q1 is close to the other ones because that's Q1, median, and Q3. That's the maximum right there at the top of that little whisker. And then this is a low outlier, but the data is super duper compact due to minimum spread, and the median is also the lowest, but comparable to Group 3. Notice how we can compare these values. I'd also quote the values if I had it, if I was writing a report on this, and talk about the values. Say the median of Group 1 is, what is the median of Group 1? Ooh. If this test asked you, compact cars have a median of what would you say? This is a very fair test question. Compact cars have a median of what? Compact cars have a median of what? Very fair test question. We'll probably do a plus around 40. The what is the 75th percentile of SUVs? What is the 75th percentile of SUVs? What is the 75th percentile of SUVs? So for the previous one, you looked at this, that's 40. 35-ish, I'd take that. It's close enough. Yeah, I can't tell, 34, 35, somewhere in there. So we're looking at that. 34 is fine. Yeah, we would do some plus or minus on this. We might even do 34 plus or minus 2 because 36, it doesn't look that high, but we would want to make sure you just didn't put in like 45 or something. What is the range of pickup trucks? Little harder one. Just give a guesstimate. What is the range of pickup trucks? What is the range of pickup trucks? So you have to know how to look at this and see what the range is. You have to be like, range. Careful. I'm trying to be tricky. What is the range of pickup trucks? Careful. And this is a good one right here. When doing range, never forget the what's. Good answer right here. We'll throw out some 50 points. When doing range, never forget what? I think that was a real comment. Well, we're gonna wait. I'm gonna I think it's Ubot got mad at all the emojis. I don't know. I think it's real. I think it's a real comment. Ubot gets angry. But what is the range right here? What is the range? Be careful. What is the range of this? Here's a better hint. What is the range of this? No one said it yet. We're gonna throw 100 points. Something like that right there. Maybe something. Those are, yes, exactly. Do not forget the outliers. That's what I'm pointing out right here. Do not forget the outliers. It's a little hard to estimate. So Caroline, you're thinking about the IQR. That's the interquartile range, which is the tiny box. So the tiny box is like a range of 1 or 2 or something like that. That's a tiny box. But the range from the min to the max is like 7 or 8. Does that make sense? So the IQR is this for this data set, and the range is the full like min to max. So the IQR is that box, and then the range is the fold. Does that make sense? Just practicing what the box plot shows us and knowing how to analyze it. 100 points again. Keep those answers coming. Keep the practice coming. The more you practice these, the better you get when you look at the data. So let's see what they ask. Compact cars generally get the best gas mileage. True. So it's one of these two. The first quartile of the cars is above all the values for the other ones. Let's see. There's the first quartile, which is Q1. It is above. First quartile is above all the values for trucks. The trucks above. Trucks have the lowest median. Greatest variability. No, trucks don't have the lowest median, so it has to be this one. Yeah. Just reading this right here, trucks have the lowest median and greatest variability. Trucks do not. They do have the lowest median, but they do not have the greatest variability. So does everyone see how I did a little process of elimination? I saw compact cars get the best, median, and then this is the lowest, but they don't have the most variability. Most variability goes to probably SUVs or compact cars with range or IQR. Does everyone understand the process of elimination here that we did a bit? And then the answer is, because there's so many things to check. Variability just means spread. Savannah, thank you for asking. Variability, think about like if I say there's a lot of variabilities in grade in the class on the test, that means they're spread out more. There's more variability. You go to a coffee shop and I say there's a lot of variability on the menu. So I'm telling you there's a lot of what's like, if I say there's a lot of variability, then there's a lot of choices. There's a lot of spread out, like there's multiple things, there's tons of options. And in data, variability just means spread options, exactly. So when you put it together, you're like, okay, wait, variability just means like spread or options or more differences in the data. So there's like, oh, there's like a lot of variability. They got a vegan menu and a keto menu and a vegetarian and not just vegetarian, but vegan or whatever. I'm confused about what the whiskers of a boxplot represent, like when the line outside of the IQR represents. So here we'll draw a box plot right here. And so we're gonna draw our own and we're gonna mark each spot and talk about it. So here is a box plot. What would you know about all this data? You bet. We got that one marked right here. You bet, Blakely. We're gonna do that one. I put it on the list. Great choice. What would you know about this? This is a box plot. That is a box plot. I'm not lying to you. That's a box plot. What would you know about that? Take a guess at it. Remember, the box plot shows you the 5-number summary. That's the 5-number summary. Good point. There is at least one value of 0. They have a lot of data at 0. And actually, not just a lot of data. What of the data would be 0? Think about this. since that's everything, 100% of the data is 0. So, yes. Oh, I can show you that right here. Let me show you that, Ellie. I'll probably show, let's do that actually. So to Ellie's question, let's go show some real box plots that are not just this really crazy weird box plot that Brian showed. And we're going to bring up some jump data right here. And then we're going to do more of the MyPearson here in a second. But notice how if all the data is 0. Here, let me say, I'm going to mark this section so we don't forget and people can review it. I'm going to call it Stat 201 Understanding Box Plots. In depth. So if you did have something like, how many yachts do you own? Does anyone want to say in the chat how many yachts you own? Like, you own these many yachts, and be serious, don't joke with me. Because usually people say this. I analyze the variation in yachts people own. Savannah says, nope. Then you'd get data that looks like this, and you would see that there's no variation, and there's the box plot above the histogram. Notice how the 5-number summary right here is all 0, 0, 0, 0, 0, 0, 0, 0, 0. I'm broke, I'm sorry. Is it because you bought a yacht, right? I know it. But there's no variation in this data. This is very boring data. Of course it is. Don't buy yachts. Stat 1 advice right here. Life advice. Give my students life advice all the time. Look at some data with some more variation right here, like attack power of Pokemon. So we're going to go here and go to Graph Builder. And in Graph Builder, we are going to drag over the attack power of Pokemon. And then we're going to do if it is legendary, yes, no. Now, this is kind of a side-by-side dot plot. Not a big fan of it. We're going to click the boxes right here. And then we're going to go over here to the very bottom and go down to 5-number summary. And then we're going to expand it to make it look all pretty. And you can even do this. You can go legendary and drop it into the color. Get a little extra color right there. I think you can right-click this. Fill color. Ooh. There we go. Look at that. Nice and neat. There we go. Fill pattern. Do a fill pattern. Yeah. Okay, sure. Whatever. Good and go. Good to go. Okay. There we go. Okay, so from this right here, hopefully this answers Alexander's questions too. We need to talk about what each spot on this is. The minimum is either the end of the whisker or an outlier. Does that make sense? The minimum is the lowest point, which will either be the end of the whisker or an outlier. Does that make sense? The minimum value is the end of the whisker, or if there's a lower value, it'll be an outlier. How are we doing that? All right. The Q1 is the bottom of the box. So mathematically speaking, that's where the Q1 is for this 97.5. The median, I should have maybe done a different color here because that's kind of blending in. The median is the center line in the box, which can overlap. Sometimes we'll do a thicker line if it overlaps with Q1 or Q3, just because there's less variability in the data. It's very compact in that region. The median is the line that is often found in the middle of the box plot, but can overlap with Q1, Q3 for data that has less variability. Q3 is the top of the box plot, and then the maximum is either the top of the whisker, or if an outlier exists, will be the outlier. Does that make sense? So what does, in this box plot, the whisker represent? Anyone tell me, think it over for 100 points. We give 100 points for guesses. What does that whisker represent? What does it represent? 100 points. A lot of people get this wrong. A lot of people usually guess the thing it's not. The whisker represents, not outliers. Good guess, Savannah. We already got a guess, so we're going to throw the points. The dot is the outlier. Those are outliers over there. The dot is the outlier. The dots are outliers. What does the top of the whisker for here represent? What does the top of the whisker represent? Give it another 10, 20 seconds. Not the maximum. This is, Kylie got it right. Kylie got it right. That is not the true maximum. It's not the 100th percentile. Look at Kylie's answer right there. Kylie said it correctly. Great job. Kylie, we're throwing you another 100 points. I was worried no one would get it. I said I'd give that 100 points either way. So I'm giving an extra 100 because Kylie is correct. Kylie said that is the maximum if you don't look at outliers. No, so that's not the maximum. So it's not the maximum. It's the highest point that is not an outlier. Does that make sense? This right here, that whisker, is the highest point that is not an outlier. Is this the minimum or the lowest point that is not an outlier? So think down here. What is this? Is this the minimum of the data set, or is that the lowest point that is not an outlier? What is this, where I'm pointing at right here? Is that the minimum or the lowest point that is not an outlier? It is the minimum. Because why? Why is that the minimum? So finish my sentence. That is the minimum because, look down here, this is the minimum because there are what? This is the minimum here because what? It doesn't have low outliers. There's no low outliers, so that is the minimum. This is not the maximum. It is the highest point at which there are, it's the highest point before outliers, where that is the highest point. Whatever the highest point is the highest point. Sometimes it's an outlier. Now the fence for this, people have to be careful because this is not where the fence is either. The fence is technically somewhere between here. Does that make sense? The fence, which is an invisible graphical technique to find out where outliers begin and start. How'd you do this in our studio? Oh, nice job. Yeah, let's do that, Ellie. And I'm gonna do that here. So let's put 207, making side-by-side box plots in our studio. So I'm gonna throw that on here because we haven't done a 207 yet. You're jumping the line and we got enough time. So here is the fence is somewhere here, but it's always 1.5 IQRs above Q3 and 1.5 IQRs below Q1. You don't show it, so it's just a technique, and remember the 1.5. So is that line, the whisker, and that Q3 is just the area between, there is data contained from here to here. This is not the 100th percentile though. This is just the highest point that is not an outlier. There is data from here to here. There could only be, that's a bigger data set, so there's got to be more than one data point. But there is data from here to here. That's what the whisker means. The whisker means from here, Q3, to the highest point that's not an outlier, there is data. That's what it means. That is not the maximum or the 100th percentile, though. That's the 100th percentile. Does that help, Alexander? Please ask additional questions if you have them. I'm going to pull up our studio right here and show some cool stuff. Then we're going to hop back. Thank you, 207. I think we got right there. I'm going to show some real, oh man, I'm so excited. I've already got a thread with stuff going on right here. Okay, so let's go. And I need to download some stuff. This is a quick tool, and we'll start back here in about 5-10 minutes. We have to go grab our data. So if you are on 207 and watching this right now, and I marked it in the video, right? I'll have to tell 207, we got a question. Because this is side-by-side box plots. It is what we are doing. This is a 207 quick break right here. And I am jumping over to the 207 class. You need to download the data. And this is the NERF data we did. And let me go over to the assignment. Click here. And oh, that's not the assignment. That's office hours. Today's office hours. And how you doing, Ellie? Make Ellie a mod. Add mod. Senior mod. Data posted. Like 3 announcements in the last 24 hours. NERF or nothing. Okay, so you have to download the NERF data, and then I'm going to go over here to the Discord, or no, I'm going to go to ChatGPT, UTverse. I'm logging into UTverse right now, and I'm pulling up the UTverse that I've been using for this. Oh yeah, so here's a cheat right here. Check this out. Yesterday I asked UTverse, here's my code that I have to load in the data. I gave it the code to load in the data, and then I said, it talked to me about the code. It was like, here's what this code is doing. Cool, thank you. And then I literally said, make 10 cool graphics from the data I've loaded. I looked at a few, and they're kind of, be careful. You got to look at what you make. You got to be like, is this good? Is this good? And then maybe 10's a lot, but we'll see. Don't just throw a 10. Just don't ask it to do it and then throw it in. Look at what it makes. So here's the first one. We'll just look at this. Oh, it's already a box plot. We already got a box plot. So let's go. I'm going to go to the Discord where I posted the code because it's posted a little bit nicer. And let's go grab the Discord code right here. So I'm going to the 207 Discord. I'm going to the 207 chat. I'm grabbing my data. And And this is the code. I wrote this code. See, if you could look at this, I said, I wrote this code and I just copy pasted it. I said, here's code I've written. I just told it that. I said, here's my code. It said, okay. We're gonna drop in the code right here and hope everything runs. This loads up read Excel because I'm using the read Excel function. That reads in the data. We are renaming the columns. If you see right here, I've got the nerf data. What? Oh, nerf doesn't exist. No! I downloaded it. Nerf XLS. What? Let me try this again. 2 seconds. Failure. Okay, we're reloading our studio. Is that not downloading the downloads, maybe? Oh, it's on local C drive? It's on downloads. Okay, it's there. Hold on. It runs now. Nerf doesn't exist. 2 seconds here, everybody. Am I no longer in my downloads? I don't think I'm using downloads as my main directory. All working directory downloads. How did that change? Okay. One moment. Not this computer. Okay. There we go. Come on, maybe I updated R or something and broke it. Okay. Plots. Okay. And let's try it. There we go. Now we've got the data loaded in. We go here to names, and we're renaming, we're turning columns to factors. Just so you can see what's happening right here in the background. Very important to know what these codes are doing is we're loading up the library. We are loading in the data. We are changing the names of the columns. We are then turning the characters into factors because that's categorical variables. We're loading string R. We're making a custom function. That's 474 stuff. We are now making we are taking from the Dart right here where it's the Dart number where it says 1. We're doing a substring to only get the number at the end and turning that numeric. We're going to lubridate right here, which controls for dates. We're double checking that this is stored at the right date time, and then we're taking the minute the Dart was fired. You're not meant to write all this code. This is code that I'm supplying for you. Because now look at this, 100 points. This looks a lot like what program? What program? Has anyone ever seen something that looks like this? What does this look like to you now? This looks a lot like what program? This inside of here looks a lot like what? At this point, you should be like, I've seen something like that. That looks like this to me. Think 5-letter word starts with an E. Could be a word or word. Excel, exactly. At this point, you should be like, that's Excel right there. I've worked in Excel. That's rows and columns of data. I'm going to clean up the data for you. Don't worry about, great job, Kylie, right there. I'm going to make the data look nice in 207. I do a lot of the harder type things. So when you're stuck, just let me know, like, hey, this graphic won't make. So yeah, just let me know. And once again, lean on ChatGPT because, oh no, where's my ChatGPT yet? There we go, ChatGPT. So we're gonna go down and we're gonna use the ggplot it made right here. Make sure to do library ggplot if you don't have the libraries loaded up. And right here, we've got blaster and distance. This is literally the graphic I would make first. And it's doing a ggplot and boom. Here we go. Side-by-side box plots of each blasters. And wow, you know, it's so interesting. And I was seeing it yesterday. Do you remember did you ever use the Thunderbow yesterday, Ellie? And look at the spread of Thunderbow. And man, it had some crazy blasts. Man, the Thunderbow, it's the Demolisher 2-in-1 was really bad apparently. The Demolisher 2-in-1 really didn't have good, that was the worst. But the Thunderbow was doing nice. But the Thunderbow is head over heels beyond the characteristics. So here's things that I would definitely look into because, and this is the code right here. Please ask ChatGPT to do it. I want you guys to give it a try, see what you get. Notice how it has this aesthetic, and I know this because I've worked a lot. I believe we can just go here and go to, let's go inside of boxplot and say color equals blaster. Blaster not found. Really? 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 It's mad. Okay, we'll put it up here in the aesthetic. Let's go to color equals blaster. There we go. There it is right there. Now I've got the color by blaster right here. We can go right here, and I'm going to make this look a little more pretty. And we're going to go fill equals, you could go like hashtag FF8200. Now they're all UT orange. You can go by blaster too if you want. There we go. Oof, we don't want to do that. Color equals code hashtag sure, that's fine. That's the color. Sure, you can mess around with it and make it what you want. That's kind of the goal of this, is you make a graphic you like. You just work with it until you get what you want. There's also another thing I want to point out. Do not turn in a graphic like this. Do not turn in this. You see this, Kylie, and the color, sure. But when you make your graphic, you want to make sure it looks nice and neat, and you might need to stretch it out. You might even need to rename some of the blasters, but you'd want to get this nice and stretched out here and make your graphic work. So you need to make sure the graphic looks nice. That's key right here. It looks all right. I wonder why it's, I think it's getting mad about the, let me do color equals here. Was it mad about, there we go, that's better. So you have to think about how this graphic is going to look nice. And let me try one last thing right here. Let me go library GG themes. There's GG themes, and you can go here to theme now, and it does different themes for you. Like I think, let's go foundation, see what that looks like. Oof, no. Themes are just different things you can do. Tufty I think works well. Yeah. So you get centered text. It's all what you want. You can do different grid lines. Does this make sense right here? What we're looking for, Ellie? You can center the text. You can change the text size. You can change the text color. There's infinite ways to go. And I've got a lot of ideas, but I don't want to do them all. But basically, ChatGPT got me started on this graphic. And you can see a lot of what's going on here with the data. And you can compare the side-by-side box plots. Now, if you want a 5-number summary of it, here's the way to do this. And we'll hop back to 201. So this is a code that is really good. And I'm going to write one more bit of code right here, more 201 right after this. This code right here is going to be the aggregate function. We're going to run aggregate. And so you can probably ask ChatGPT for this too, but if you want, type this code that I'm doing here. Aggregate, and you do y tilde x. I think that's the code we're going to do right here. And we're going to do distance tilde blaster, and data equals nerf. And so y tilde x comma data equals, and then you have to aggregate by the fun. Fun equals summary. Will that work? Let's try that. It's mad about it. He wants this. Let me see. There we go. There's the median. Nice. I like it. Okay, so if you look at this code, it's on the screen right there. Here is a summary of every blaster. And frankly, if we turn this into a data table, we could sort it by the median blast. So what we can do right here, here's the code up top. I'm going to store this as a data frame. And so there's the data frame. And then I'm going to do one last bit. So I know I'm doing a lot right here, but this is what I would do with the data, and probably everyone's going to do it now. Just some ideas, so get people started. Using dplyr, which is data manipulation. And we're going to go sort. We'll go to a new line because I was like doing this way. No, we want to go to arrange. Let's forget the name of this one. Arrange in descending order by distance, median. Oh, and then we have to do the column inside of here. Oh no, it did weird column names. Distance, which one of these got arranged by? Distance min got arranged by. Can I go and do the fourth column? Ooh, that is how I do it. I'm getting smarter at coding. No, it's not doing what I want, I think. What is it doing? No! Let me do one last thing. I love working with data so much. It's a problem. Let me look at the names on this. Oh, that's a list. Oh, really? Give me a list. Because probably data frame $sign or square bracket distance square bracket 2. No. Oh, it's a matrix? Really? Oh, and this is row 1. It does want bivariate. It wants that. Okay. So that means the arrange would have to be, okay, range by distance third. Descending. There we go. There we go. That's what I wanted. Man. Once again, please ask for help. This took me a moment. And we can see very clearly here that the Thunderbow had the greatest median distance. So please, please, please ask for me for help with this. You could move out some of these columns and just compare things. Like, this is the start of the work, and please ask for my help on this. Be like, hey, Brian, we want to make this. What do you think? I'll write a lot of the code for you. But now I have the table the way I want it. I would store it and data from 2. Let me cheat. Let me grab this right here, go over to ChatGPT, cheat, so I don't have to think as much. And I say, take this code and turn it into an amazing flex table with highlighting the row with the lowest and highest median. Make sure it has cool colors and headings that are bolded. Okay. Oops, hit it twice. Okay. So once again, ask it for cool things. Ask it to do things. Think about how graphics look nice. Let's see if it knows what to do. It take data frame 2 and do a flex table on flex table data frame 2. It's installing my packages if I needed it. Loading dplyr, loading flex table. It's already got I already did that. That's my code already. It's figuring out which one's the lowest and highest median. That's good stuff. Grab that. Now it's doing the flex table. There we go. And it did a bunch of cool flex table stuff. So it looks like it did what I wanted. Fingers crossed. And then it's explaining it. Cool. I know what flex tables are. Once again, this saved me time on writing it. I basically had to just know what to ask for. And I'll just tell you this much. I am astounded by like what we can do. And there it is right there. It's got the highlighting, and auto fit is not working. So we're going to remove the auto fit because let's hope that's the only problem. Could not find, oh, because flex table I didn't load up. Probably is inside a flex table. That was, yep. Oh, now it's mad. It got mad about something. Number of items to replace is not a multiple of replacement length. Which code broke on that? That's where you have to go here and run your code in parts. And it's breaking early on. It broke there. Just completely broke. Regular table, flex table. So it's mad about this. You know what it might be? Because this is a matrix. So that's why it might be mad about it, which is really a bummer. Man, it's so close. So close. Let's go and take a data frame actual, like empty cars, and see if it can just do it on that. No, it's getting mad. Well, that's the problem with it's cool code. Looks like it almost works. But Ellie, I hope that helps out a lot. Once again, if you were stuck on this, I would need to take a look. Went to ChatGPT and it sent me the wrong way, but it almost looks like it's going to do what I want. The code looks so good, but got to look into the errors. Got to be like, what is the error? What's going on? Number of items to replace is not multiple replacement ways. You're welcome, Ellie. And just do a little work, ask questions. Do a little work, ask questions. We already got some graphics we want. We got pretty good looking graphics over here that I made by scratch. A little bit of ChatGPT. But then this table would have been really cool had it worked. Let's move out these two, just see real quick. Okay, it works. It's something, I think it's the matrix. So this flex table works. So I think it's because there's a matrix inside of there. I think the object is wrong. So this would be a table you could put in your report. And I just wanted to make, I want to make that table. Let you guys, I can make it another 5-10 minutes, but we're going to go back to 201 here. So really fun stuff. Love doing this kind of stuff, but this is a table you can put in your report. And I wanted the rows to be highlighted with the lowest and highest median. So you're pointing it out to somebody. Okay, let's head back to 201. Let's do it. 201, time right here. Thank you, Ellie, so much. Do men and women marry at the same age? I don't know, do they? Okay. Do men and women marry at the same age? We will find out. Class 4th graders coming up. Here we go. Do men and women marry at the same age? What do you notice about these box plots? Men have a much higher what? Men have a much higher what compared to women? Mary, you get points for answering. Throwing 50 points for everyone chatting already. Men have a much higher what compared to women? Well, yes. What age? What age though? You're right. You're right. But what is higher for men? Compare right here. Start comparing. The ranges look similar. A similar ask. The IQR is median. Median. Remember, look at the data before. Great job, Kylie, right there. Median. So that's about 29. That's about 27. Yeah. So men appear to marry about 3 years younger. But the two distributions are very similar in shape and spread. Yeah. I mean, it literally looks like you just moved the distribution up. So that should be right. Good question. Good question. Good, simple, fun one to do. The National Vital Statistics Report. So, National Vital Statistics Report. Let's do it. Oh, here we'll do it. Chapter 1, Chapter 4. Wheel. We have done a lot of these today. National Vital Statistics Report. Okay. We'll find it. Oh, we have that one coming up. Frozen pizza. National Vital Statistics Report collects data on deaths by age, race, and sex, displays the information of deaths of white and black males are provided. Okay, so if you take a look right here, we have the age of death, and the data for the green distribution looks to me definitely what distributed. The data for the green looks to be what distributed. And they're both this type of monster, man. So the data for the green distribution for black Americans looks to be more what? How would we describe it? They are both left skewed. Alexander, you're right. They are both left skewed. They both have left skew to them. What's the differences though? They both have left skewed. Bimodality. So there's more bimodality. There's more extreme on the low side right here. Like these are the differences. Difference 1. There are extreme low outliers. Difference 2, the bimodal nature of it. Similarity between them, they both have left skew, left to the low, right to the high, whatever way the monster man's tail goes. We would use the median and IQR respectively to compare these distributions. So the overall shape of these distributions are, both distributions are skewed to the left. So that's the answer right there. The white has 1 peak and the black has 3. Kind of, I mean, 2, 3, sure. How do the distributions differ? It's definitely going to be the modality, I would say. The center of for the distribution of blacks is less, yeah, kind of. They both have the same range. If you take a look at the data right here, the center is going to be towards here, where the center is here, due to the second modal area. A little hard to tell. Look carefully at the bar definitions. Where do these plots violate the rule of statistical graphics? So when they do this, you need to have even widths bars, and it's very hard to see. Can we go over the one that says box plots show the fuel economy? Yeah, we'll try to do that. I don't think we've done it yet, so that's good. Yeah, we'll try it. Let me grab right here, Kylie. So when you do box plots, you're supposed to have even widths, and you've got 1 to 4. Let me do it where I can show you. You've got 1 to 4, and you've got like 88, 84, 85 and over. You're not supposed to do that under 1 year. They don't have even widths, so that's a huge problem right there. It's not good. The widths are not constants. I think they do cover all ages. The vertical axis doesn't start at 0. Kind of doesn't. I mean, it's hard to tell. I'm gonna get mad about this. They don't have the same maximum. Yeah, they don't have the same maximum. We might get one wrong right here because I can't tell if it starts at 0 or not. It looks to start at 0, but box plots and histograms should have the same what's. The same this. We talked about the slot yesterday. Should have the same this and this. If I get this wrong, it's because it did not start at 0. Got it right. Still 300 points for being here. So they should have the same what and what. Remember this. We talked about this a lot yesterday. I was like true and true and true. It should have the same what and the same what. Box plots and histograms, when comparing them, should have the same this and the same this. It's almost like it's a test question. Box plots and histograms should have the same this and the same this. What should they have? Kind of. Savannah, you're on the right track. Not so much X and Y. 20 points right there. I'm talking about this right here. We call it the, starts with an A. Starts with an A. And it's horizontal. Horizontal and vertical axis. Great job, Kylie, right there. Good note. Put it on a note card. Box plots should have the same, and histograms should have the same horizontal and vertical axis to compare them. Great job, Savannah. More points in the chat. Box plots and histograms should have the same horizontal and vertical axis. Which follows necessary of outlier. Oh. Maximum doesn't need to be an outlier. Think of all those zeros we saw, like 0, 0, 0, 0, 0, 0, 0. Then none of them are outliers. Everyone is around. We're looking for the in a way question. In a way. We've done so many of these. Wait, where is it? How did we miss it? In a way, here it is. We got 24 minutes and I got a meeting at noon, so we can do this. We'll have done so much of this quiz. You should look at this sheet over here. It's crazy. And we did 207. It's a great day. Okay. In a way, box plots are the opposite of histograms. In a way, they're kind of different than histograms. That's what I would say. Box plot divides the number line to equal intervals and displays the number of data values in each intervals. Like, you know, the quartiles, it divides it into quartiles. Box plot divides it into, yeah. These two plots display the number of incarcerated prisoners in each state at the end of 2014. Use these displays to compare A through D. So histograms let you see the what of data better, where box plots hide important features. Histograms are better at seeing the what of data. Histograms are 5-letter word, starts with an S. Histograms much clearer show you the what of data. It's easy to see, it's right skewed. The shape, where box plots often hide important features but are great and ideal for comparing multiple distributions and seeing things like outliers right here, the 3 outliers. So what can you explain how you could tell by looking at a box plot where the tallest bar on the histogram would be? So each of these spots on a box plot represents a quartile. Quartile meaning 25% of the data. So here's a quartile, and to there, to there, to there, to there. This quartile is very spread out. This quartile is very compact. Within each one of these, from there to there and the far one, is 25% of the data. So the distances between the min to the Q1, and you can kind of see it right here, is a lot of the data. You can see with the peak of the histogram. So the differences between the 5 number summaries telling us what percent of the data we've gone through, 0 to 25 to 50 to 75 to 100%, is going to be where the tightest, where the most compact is when you look at the box plot and it's squished in that area. Now the fence, which we don't always draw, but I want to show you, is probably theoretically somewhere in here, because you would have to go 1.5 IQRs above, and actually the fence is going to be a little bit higher. The fence is technically probably right over here. Higher than I thought. It's a graphical technique. You don't see it. Just after the fence exist outliers. But there is a big what in the data right here. There is a big what because the whisker only goes to there. There is a big what in the data. There is a big what gap. Already saying the answer. You got it, Kylie, right there. There's a big gap. There's no data there. The whisker only goes up to the highest point within the data that is not outliers. So this point right here, we've mentioned a few times, is going to be the highest point that is not an outlier. That purple mark is the highest. Oh, not that. That's Q3. Q3. That purple mark right there is the highest point that is not an outlier. That other thing I marked was Q3. The whisker, when not an outlier, is the highest point that is not an outlier. Good review, and so here's kind of the answers to this. We're looking at the box plot. So the areas in the box plot where the two vertical lines are the closest together tell us where it's the most dense. Like the closest two lines from the min to Q1 is where the highest peaks are. Explain how the box plots in histogram can indicate a skew. Histograms are just easier to look at. The box plot indicates skew because the min, the first quartile, and the median occur within a smaller data set. Box plots indicate skew because the minimum, the Q1, and the median occur within a small range of the data, while the median, the Q3, and the max have a much larger span. The histogram indicates the skew since the tallest bars are on the left side and Monster Man has a right tail. Identify one feature of the distribution that the histogram shows but the box plot does not. There's easier to see the shape of it, something dealing with shape. They both show outliers. Histogram shows that the distribution is roughly uniform. It's not uniform. Not really uniform, it's very unimodal. Histogram shows that a very large number of values occur in the smallest bin. You kind of see that. Histogram shows that the location, no, histograms don't show it. I don't love this one. I mean, you can kind of see it better in the histogram. It should say which of these is better displayed. Pretty sure this is the answer. We can see outliers in both of them. I'm really gonna be mad if it's D. It's not uniform. I mean, no, it's not really uniform. Box plot's gonna show the 5-number summary. The location of the median, which is part of the 5-number summary. Yeah, we got it. I'd have been Superman. Really didn't like C because you can kind of see it. It should say what is easier to see. The concentration of data is easier to see in the histogram with the high peak. It should say what is easier to see, not what is that the histogram shows. It's what is easier. So yeah, good. All right question. All right question. Could have said what is easier to see. Okay, we got another study reports load factors. MyPearson Quiz. Has anyone already gotten 100? You're here just hanging out? I think load factors is at the end. Here's load factors. Study reports load factors for commercial airlines for every month from 2000 to 2019. The accompanying box plots display the domestic load factor by year and all domestic load factors and all of the domestic load factors. The box plots for each year show the same data, but the outliers they show is for a different month and year. What do you think this is? Okay. So this is all the data down below, all the data put together. This is the data separated out by year from 2002 to 2019. You can see 2015 had a low outlier, but there was also less spread to the data because if that was in an earlier year like 2005, it would have been part of the typical low, not the extreme low. So there's less variability seen by the range decreasing, which is the min to the max, shown by min to max. And also there's less variability shown here by the IQR getting smaller. IQR is larger at the start. Also, the median is increasing. We see as time goes on, the median increases. And a lot of the outliers would be hidden, or a lot of things are considered outliers, rather, when we don't break it up by year. It's better to probably break it up by year and look at it respective to each year. Box plots. I'll take 100 points. Savannah knows those are box plots. That's a bivariate display of categorical X, quantitative Y. And a box plot singular is a quantitative display of univariate data. Singular box plot. Let's see what they ask. Outliers are context dependent. True. Data values that seem ordinary when placed against 1 year's data may stand out when compared against the entire data set. Data values that seem ordinary when placed against the entire data set may stand out when compared against the data for 1 year. May not. There's less outliers in the full data set. Outliers are context dependent. There's like a ton of outliers here. There's only one up there. So data values that seem ordinary when placed against the entire data set may stand out when compared against the data for 1 year. No. Data values that seem ordinary when placed against 1 year's data may stand out when compared against the entire data set. Yep. Yeah. because these data values up here may seem ordinary until we compare them to everything. How do we change the bar chart from vertical to horizontal and jump? Top right arrow, click stack. Top right arrow, click stack. Awesome, Catherine. Check out Tuesday's office hours. I go over each graphic in depth. So check out Tuesday's office hours. I do a full walkthrough and full explanation. Let me know if you have questions. Top right arrow and stack. Top right arrow and stack. Help travelers know what to expect. There's 2 versions of this question, maybe 3. I don't like this question because I have gotten this question wrong. Oh my gosh. You're welcome, Catherine. Thank you for asking. Okay, to help travelers know what to expect. It's right here, right? Oh, here it is. To help travelers know what to expect, researchers looked at the price of, what is it? Water, eggs, and bread in different countries. And this one's a little tricky. I don't like this question because I have gotten it wrong. In general, which commodity is the most expensive? So general, I would look at the median. So eggs, on average, a dozen eggs is the most expensive of the 3. The median price of eggs is definitely above the quartile, the 3rd quartile for the other ones. These prices are prices for the same countries, but can you tell whether eggs is more expensive than water in all countries? So here's the problem. And this is where I get a little tripped up on how they ask this. The maximum right here is higher, but when you do the combination, it'd be hard to tell. No, you cannot tell whether eggs are more expensive than water in all countries. The box plot do not show how many of each commodity is in each quartile. No, you cannot tell whether eggs are more expensive than water in all country. Correct. I believe that's it. Yeah. Because we don't know the pairing. We don't know, like, in Germany, maybe eggs are $2 and water is $1.50, but in America, it's reverse. Just the way they ask that one, I don't like. It's just you can't tell, like, each data point comparatively. Now, here's the thing, and it's because they have some overlap. Now, if eggs are always more expensive, like if the minimum of eggs, like the children's cereal question where the minimum, like, is children's cereal always more sugary than adult cereal? Yes, because there is no overlap. So because there's overlap, there could be a country that has higher water than eggs. But if there was no overlap between them, then we would know that this is always more expensive. So we'll do the other one, which one of these I get wrong sometimes. So same sort of idea, countries measured. In general, which commodity is the most expensive? Once again, it's eggs. Overall, a dozen eggs because median is much higher. Got a lot of outliers up there. Is a carton of eggs always more expensive than a bottle of water? And once again, we go to the overlap right here. It is not possible to tell. Yes, maybe they changed this. Yeah, so it's possible that since eggs has a higher minimum than water, that maybe the country always has higher eggs, but it could be that this country has expensive water and low eggs. It goes to the pairwise comparison. Is a carton of eggs ever more expensive than a loaf of bread? Yes. Well, so eggs to bread. Is a carton of eggs ever more expensive than... It's not this. Yes, all the egg prices are above all the bread prices. No. There's not several egg price. Oh, wait, here it is. Yes. Eggs to bread. I was doing water. This is the second version right here, right? Yes, there are several egg prices up here that are more expensive than bread. So this right here, whatever country this is, it would be more expensive. The eggs here, probably America. Haha, maybe they changed this. The eggs right here would be more expensive than any price of bread. No matter what that country has for bread,
It doesn't matter.
their eggs would be more expensive. I think I'm worried about part B. Yep, worried about part B. There we go. No, some of the water prices are above the minimum price of carton of eggs. Is a carton of eggs always more expensive than a bottle of water? I don't like that. Some of the water prices are above the minimum, but you don't know the pairwise comparisons. I don't like it. Make sure you get it right. That's the answer to it. I tell you, this question, is a carton of eggs always more expensive? Is it always? it could theoretically be like the true untrue for the last one makes sense for this one. Like this one really says it right. Like it could be true or untrue depending on how we pair them. So yeah, like, or did we do a third one of it? Ow. Sorry, not a huge fan of that one. Once again, I've seen that one multiple times. I think the lag stopped doing the lag. 149.53. Okay, or 49.53. I don't like that question. Here we go. Chapter 4. We got to get one wrong. No, that's too wrong today. Okay, a class. Look at all these questions we've done. Here we go with the class of 4th graders right here. And what we have right here is the 5-number summary. Now, I wish they did this. What should they mark above all these? Help me out right here. What should they have written above all these? Now, since this is the 5-number summary, what should they have written above all these? Think about what would go above all these. I'll give you some hints. What should go above all these? So they should have done this for you. This is the 5-number summary you're seeing. So they took data and then they summarized it. The 5-number summary consists of what? There we go, Kylie, great work. The min, the Q1, the median, the Q3, and the max. So they should have done that, and you can now compare the IQRs. And the IQRs, so this has an IQR of 1.1, and that has an IQR of 1.2, just distance from these numbers. Once again, remember the IQR is Q3 minus Q1. So you're just comparing the distance between those numbers, and the median is the middle number. So know where your median is at right there. So that's got it. There is the IQR, there's the median. The blank had the highest score. Yeah, I think, did we do that already? The research, we might not have enough time. We might, no, I'm gonna try to do it quick and might find you a video on it because I've only got 9 minutes. Try to do quick. Had the highest score, that is going to be the boys. Good show. Which group had the greatest range? Max minus min. So it looks to be the boys again because that's 3.2 found by 5.8 minus 2.6 versus this one is 2.8, 5.7 minus 2.9. Which group had the highest and biggest interquartile range? Once again, take the Q1 to Q3, and it's going to be the boys again because the boys have an IQR of 1.2. Sure. Which group generally did better? Medians are good to compare here. The boys did generally better because the boys' median was higher than the girls' median. The boys did better on the reading test because the median for the boys was higher. Now, this is the tricky one. This is the tricky one. And I lucked out on this version. Well, actually, nope. They want you to round to 1 decimal, and I'm pretty certain I know the answer. This is where people get this one wrong. They say, how? Pretty sure. Oop. Really? Oh, wait. It says to 1 decimal, right? Not that. I got something else wrong, I think. Really? Whoops. Well, let's take a look at this. Yeah, it is going to go to that. But let me show you why I shouldn't have done that. Darn it. You say, Brian, 4.4 and 4.2, can you not average that? But wait. This is where you have to be careful. You know what? I'm going to show you a version. Well, we'll do this version. The reason is because in this question, there are 13 boys and 11 girls. So when you're doing this question, you have to take the mean by doing the following. The boys had an average of 4.4, and there was 13 boys. The girls had an average of 4.2, and there was, wait, was there 13? There was 12, wasn't there? 13, yeah, there was. 11, and that's a total of 24. So you have to take the average this way by turning the data back into the data points. Tricky part at the end, and sometimes you have to do this and get it right. Other times you get lucky and think, well, I'm just averaging these 2 numbers. I wish it always had the trick in it. And then the exact is 4.3. So they should do to 1 decimal, and then you'd have to really do it. The exact answer is 4.31, but you can get this wrong if you just average 4.4 and 4.2. So this last part here is where people make the error. I made the error, but did it by, yeah. We do the other version of this one. Is there another version of it? I don't think there's another version of it. there's that one. It's complete now. You might have to send it to me or something because we only got a few more minutes. I don't think there's another version. We've almost done everything. We've done a lot of the hardest ones. The box plot shows fuel economy. I have just enough time here. We're gonna do the last one. Which one are you wondering about, Blakely? I'm gonna do this last one, then run away. So we're gonna do the fuel economy one. Fuel economy. Okay, the box plot shows fuel economy. Oh, there's my alarm to go to the meeting. This box plot right here shows fuel economy for cars, and there's an extreme value on the far side of this, an outlier. So what would that outlier do? It would drastically change the mean and standard deviation, hence why we would use median and IQR. How would removing the outlier change the standard deviation? It would decrease it because the data would be less spread out. Standard deviation is a measure of spread. Standard deviation would very much change. It would get smaller because standard deviation is spread. Outliers spread out data more. Removing it removes the spread of the data. How would it affect the IQR? The IQR is the middle 50%. The middle 50% is not impacted by outliers because it's the middle 50%, and outliers are on the extremes of the distribution. So the outlier would not change very much at all. And that's got that right there. That should do it. Yep. The outlier would not change that. That's got it. The research and innovative. Did we do that? I thought we did it earlier. Okay. Here we go. Let's do it real quick. So bonus one right here. Got just enough time. Speed running these. Here you go, Noah. Thank you for being here. Appreciate it. Chapter 4, MyPearson Quiz, the research and innovative. Okay, let's look at what they say. Here's the data. April, August is more left skewed, and September, March has left skew with a lower median. Both distributions are skewed to the left. More variable. More variable is going to be the one that's more spread out. So more spread out is the September, March, right? Because it's across the number line more. It's more spread out. So September, March, which September through March is the winter seasons, have more variability. I think so. Don't tell me I got wrong. We can't end on MyPearson saying loading. I gotta go to a meeting, MyPearson. Communication error. We got it right. With that, we're gonna head off. Bye for now, everyone. Bye. You bot, go away. I am you bot.